Welcome, everyone, and thank you so much for joining us today for this webinar where we'll be covering some key trends in the application security industry. In any trend list, there should be really few surprises. After all, most trends are a continuation of what was important just a month or even a year ago. As a quick introduction, my name is Brent Jenkins, and I am the Director of Product Marketing for Fortify. And joining me today is Sheldon Mills. Sheldon Mills is our Product Marketing Manager for Fortify On Demand, our application security as a service offering. Before we start, just a quick little bit about who we are. Fortify is a core pillar in CyberRes, which is a micro-focused line of business. We bring the expertise of one of the world's largest security portfolios to help our customers navigate changing threat landscapes by building both cyber and business resiliency within their organization. CyberRes is part of a larger set of digital transformation solutions that fight adverse conditions so businesses can continue to run today and transform to grow and take advantage of tomorrow's opportunities. With over 14,000 customers and over 1,800 dedicated, passionate security experts, Micro Focus has invested heavily in growing CyberRes as we help organizations protect identities, apps, and data, detect, respond, and recover from advanced threats, and evolve their security posture at the speed of change. So, the AppSec industry has been on a journey towards cyber resilience for 2+ decades. From rudimentary compliance-based scanning to a stage gate approach as attackers increasingly began exploiting app vulnerabilities. The pace of evolution rapidly increased as modern software development practices and technologies emerged, driving attempts to shift security left with varied levels of success as developers increasingly began to take ownership of the security of the software produced. Now, we've reached a bit of an inflection point in that journey. So as the application security industry continues to evolve at pace as organizations recognize that software security risks need to balance with business imperatives that accelerate the speed of digital innovation. This isn't new. It's just the pace of technology transformation encompassing an explosion of APIs, microservices, infrastructure as code innovation, and cloud technology mapped to the ever-increasing demand for faster time to market. All of that is just accelerating even more. Organizations are continually pushing boundaries while recognizing that the speed of application security testing delivery can't be traded for the depth and quality of code security analysis. So many things on this list reflect what our customers are asking us to focus on and deliver. And most of these topics deserve much more than a few paragraphs. We'd love to hear what trends or details you would have included, but with that, let's go ahead and get started. And here's our list of key application security trends for 2022. So first, we have securing the software supply chain. Next, we have API security needs are growing ever larger. AppSec is evolving from shift left to really shift everywhere. There's still the ever-growing cloud-native AppSec. AppSec orchestration and correlation. Next generation DAST or dynamic application security testing. And machine learning and AI are key to the next evolution of automation. So that's our trend list, but let's go ahead and dive right in. Concern about inadequacies of software suppliers' capabilities to build, deliver secure software really isn't new. For example, in the late 2000s, the U.S. Department of Homeland Security's Build Security In initiative had a working group that our very own Stan Wiesman co chaired on this topic. The intent of the working group was to help acquirers buy software that was more resistant to attack, had fewer vulnerabilities, and minimized operational risks to the greatest extent possible. In recent years, the severity and frequency of software supply chain attacks have increased significantly still. Utilizing open source components to accelerate the development process has proven to have great advantages, which is why a staggering 98% of all code bases rely on them. However, supply chains have many blind spots or cracks that attackers can take advantage of. Some of the most recent software supply chain attacks, Log4j and SolarWinds, received wide press coverage, causing government and businesses to continue to respond even harder by scrutinizing their supply chains and putting in place the required processes to protect against risk. However, there are many emerging threats beyond software composition analysis, such as insider threat analysis or malicious code injection, insecure compliance, Trojan source, and hacker-level insights, third-party client-side JavaScript downloaded and executed at runtime in the browser. For example, normal vulnerability components can create an exposure as soon as you put that software into production. Traditional composition analysis, which is done after development but before deployment, is an effective defense in this scenario. However, problems with malware components can do a lot of harm on the developer workstation itself. Software composition analysis isn't an effective defense for such an attack like this. You'll need traditional anti-malware software instead. So, if we think about this, the future supply chain security will move beyond CVE scanning of the software you consume. It will encompass attack vectors such as malicious code injection in the source code you develop, the integrity of the code as it moves through the SDLC, the infrastructure driving deployment and operation, and the range of third-party code, components, and interfaces that your software interacts with at runtime. Equally important will be the ability to proactively find and select the best and most secure open source code for whatever application you build, such as how Debrick's open source select works. So open source select from Debrick, it allows you to search, evaluate, and compare different projects based on contribution, overall health, and security of the project, and more, allowing your developers to really make more informed decisions on the code they introduce to your applications. To cover this topic in a lot more depth, we actually have we've dedicated our next webinar in this series to this topic. Furthermore, we have some excellent discovery, technical, and demo videos on this topic as well on our YouTube channel. But this webinar is really about just kind of touching each one of the trends lightly as we dig more throughout the year. So let's move on to the next trend. So the next trend is all around API security. As Gartner states here, by next year, over 50% of B2B transactions will be performed through real-time APIs. A similar stat on the rapid growth of APIs is from Postman, which is reporting typical growth of over 39% this year. So first, why don't we take a step back and look at what an API is? Representational State Transfer, or REST, is a software architecture developed by hypermedia data on the web. This architecture is now the most common method for the implementation of application programming interfaces, or APIs, which allows for the transfer basically of data between a client and a server. A transaction between client and server comprises a request being made to a given endpoint, which consists of a base URL, the domain of the server, a method, the path portion of the URL, and operational parameters. A request specifies the method, often called the verb, to be used. Additionally, a body, typically JSON or XML, can be enclosed in the request. Once the server has validated the request using authentication and authorization schemes, it will process the request and provide a response in return, including an HTTP response code that indicates the status of the request. Additionally, the response may return a data payload in a variety of formats and encoding schemes. So now that we've got that out of the way, APIs are really an attractive attack vector for adversaries since they are frequently publicly exposed with documented endpoints. Excellent attack tools allow for ease of automation of attacks. The combination of the prevalence of APIs, the relatively easy target they present, and the value of the data exposed means that API security is a top priority for security and risk professionals. Many people are familiar with the Open Web Application Security Project, or OWASP, and their top 10 list. But API security is such an important and continually growing issue. OWASP has a separate API top 10 list. I'm not going to go through the entire list here, but be sure to visit OWASP's website and check it out. So modern cloud-native apps typically employ a distributed architecture, services, microservices, and serverless functions. These components communicate with each other, end users, and APIs, creating the need to assess security at the component and system levels. At the component level, inter-service communication can use a variety of protocols, ranging from HTTP to SOAP to gRPC, and at the system level, an API gateway is typically used to consolidate individual service APIs into a unified business app API. Based on HTTP, usually REST. In recent years, however, there's been an increasing popularity in GraphQL, the Facebook-created language that was released to the community back in 2015. So API testing and discovery is a multi-step process. The first step in securing APIs is to incorporate SAST into the DevSecOps pipeline for each independent component. Then, API security incorporates DAST scanning at both the component and system level APIs where HTTP is utilized. The next step is attack surface discovery, which means providing the endpoints and parameters that constitute the API attack surface, the what. In addition to the what, proper discovery also incorporates how the API is used, the how, which is important for the business logic workflows and sometimes complex authentication at the system level of the API gateway. Like our last trend, we have an upcoming webinar on this topic alone coming up in the next few weeks, so be sure to register for that. Again, I'm not going to go into a lot of detail in how we at Fortify are addressing API security and some best practices and understandings, but we'll definitely do so in that webinar where we'll dig a lot deeper into the topic. So now I'm going to pass it over to Sheldon so he can discuss the next few trends. Over to you, Sheldon.
Thanks, Brent. I'm happy to join everybody today, but let's just jump into our next top trend. This one is highlighting the evolution of application security from shift left to what we're calling shift everywhere. But first, here's a great quote from Manish Gupta from the company Shift Left, sharing some of their research. When increasing the speed and frequency of scans and prioritizing SCA tickets, we found enterprises that tightly integrate security testing within their CI/CD pipeline fixed 91.4% of new issues, which is just highlighting the importance and effectiveness of integrating security testing early in the pipeline. We've also found that shift left has not only affected where in the SDLC application testing and security is being implemented, but it's also had this huge, profound impact on who is responsible for security testing, right? Developers are now often the primary drivers when it comes to the purchase and implementation of AppSec testing. Why? Because security testing has unequivocally become a critical component of DevSecOps, but it's encroaching more and more into the developer's realm, the developer's world. But the reality is that business usually trumps security, sadly, and developers are incentivized to deliver functionality with as few bugs as possible and as quickly as possible. So the real trick is figuring out how to insert security into the developer pipeline to enable developers to fix vulnerabilities without slowing them down. Again, it's the importance of integration into developers' existing toolchains. But that's been the push to shift left for some time now. But that's starting to change. And with the shift to the cloud, some testing is actually starting to shift right. There's containers, serverless, infrastructure as code. We're starting to see expanding coverage across the software development lifecycle, with added testing to these newer technology stacks. But we'll get into that a little bit more with our next trend. So at the end of the day, the push for seamless integration into every stage of the SDLC is starting to become the norm for AppSec tools everywhere. And because of this, security testing and the push to write secure code and early integration, AppSec teams continue to have less influence when it comes to tooling in the DevOps toolchain. And as developments pushed back, many vendors started to offer these hyper-convenient scanning technologies, but unfortunately, some of these early offerings, these early tools resulted in only a fraction of the vulnerabilities being found that you would find from a more robust AppSec offering. But the convenience, right? So the convenience, the cost savings, check that box, and it helped many organizations check the compliance box. But like we mentioned, most organizations now view security as being critical. So now we're seeing this tug of war between convenience and robustness, and it's pushed the entire AppSec industry toward tighter integrations throughout the software development lifecycle. And as a result, most of the top tier AppSec tools are becoming more and more seamless. I put that in quotes. They're seamlessly integrated into the CI/CD pipeline, some better than others, but that the whole push is moving toward that, this tight integration. And we're seeing the shift left mentality actually become a reality in many organizations with mature AppSec programs. So as these vendors and tools mature, the integrations and enabling experience are becoming better and better, so that integration is now becoming table stakes. And the quality of results, the ease of enablement and fixing and reducing risks efficiently is once again becoming the things that matter most, the things that are driving DevSecOps. It's less about checking the box, more about finding the right tool for the right job. It's about better defense and depth. And like we said, it's not just left now, it's both left and right. It's everywhere. All right, on to our fourth trend. This statistic comes from a recent SANS survey, which you can download from our website at cyberres.com if you didn't know that. This one is highlighting the fact that more than half of organizations use 3 or more cloud platforms. So cloud continues to grow at lightning speeds, and the complexity of the cloud environment is also continuing to grow as well. All right, this trend is cloud native AppSec. There's a broad IT industry trend towards the cloud, with organizations being at various stages. And the modern software stack includes cloud native elements of the architecture. The CNFC defines cloud native as this: as technologies that empower organizations to build and run scalable applications in modern dynamic environments such as public, private, and hybrid clouds. Containers, service meshes, microservices, immutable infrastructure, and declarative APIs exemplify this approach. We all know the big 3, AWS, Azure, Google, GCP, they dominate the market. And each one offers similar functionality and SDKs for interacting with the cloud infrastructure components. And while cloud computing offloads many of the tasks to the cloud provider, the end user organization retains responsibility for securing the data that goes into the cloud. This affects AppSec in many ways. One of these is there are specific AppSec requirements for apps to run in the cloud. And what these are depends on how the application is architected. On putting an application in the cloud, the simplest approach would be to lift and shift, running on cloud infrastructure. So a few things change in this scenario. Of course, this is a continuum more than a binary choice, and the bigger organizations will have larger application portfolios that are spread across this continuum. In our AppSec Trend white paper, which if you haven't already downloaded, there'll be a link at the end of the webinar. Please look at it more in depth. We've identified some specific aspects of application security when going cloud native, like the use of SDKs, infrastructure as code, containers, serverless, function as a service, cloud secrets, and cloud CI/CD. And if you look at the consequences of these new aspects of AppSec, we see that all of them place new demands on AppSec tools. And that demarcation between AppSec and InfraSec, it's becoming blurry. There are many niche vendors popping up that do one thing really well, but at the same time, organizations, they're concerned about this tool sprawl, and they prefer consolidated solutions. All right, let me pass it back over to you, Brent.
Thanks, Sheldon. So, application security orchestration and correlation has increasingly become a hot topic in the industry. These are often spoken of simultaneously, but it's really the combination of two separate topics. So, for the sake of this discussion, we've split them into two separate actions. Orchestration. So, with the continued speed and complexity of modern development, the demands on AppSec teams continues to grow. Many organizations utilize numerous different types of tools from various vendors to cover their AppSec needs for software composition analysis and SAST and DAST and more. Attempting to manage each of these tools separately creates complex problems and bandwidth issues. From a broader standpoint, one security professional might only have access to security tools utilized in the applications they cover. AppSec orchestration plays an important role in enabling these small teams of AppSec professionals to meet the increasing demands and deliver scalable, dynamic, and static scanning solutions to large teams of developers across the organization. This comes from utilizing a single source to schedule automated and scalable scans across numerous tools used throughout the organization. Development organization leaders and executives mainly care about the risk of the environment. Risk management provides a comprehensive view of risk from applications and their supporting infrastructure. With a focus on this approach, executives can create a clearer picture of their assets, business context, and ROI. Solutions such as SaltMiner from Saltworks Security do this by pulling in contextual data beyond just AppSec. And with vulnerability management, we are seeing the continued evolution of solutions that aggregate, analyze, and report results into a single pane of glass, providing visibility into all of the application security initiatives within an organization. This provides a holistic view of organizations to assess their AppSec data at an executive level. To further expand the basic idea of AppSec correlation as expanded vulnerability management, there's the aspect of systematic problems and patterns that can emerge. By layering the results of dynamic analysis on top of static analysis, customers gain a valuable additional risk metric that allows them to see a more complete real-world risk picture. While it's important to identify vulnerabilities early in the SDLC using technologies such as static analysis, it's also critically important to create feedback loops that can identify when those findings surface in running environments via a DAST scan. An organization that identifies findings such as cross-site scripting early in the SDLC and continue to detect those issues in production can focus their training and development resources on addressing those systematic problems. A unified application security vulnerability management platform is critical, not only in the terms of the simplified prioritization and triage workflows that it introduces, but also in terms of the patterns that can be gleaned from the data. More intelligent scanning means DAST validation of SAST findings and DAST tuning by SAST results. So for our next trend, we have next generation DAST. So DAST is continuing to integrate earlier in the pipeline. Historically, the turnaround times of DAST scans have precluded their integration into the DevSecOps workflows. However, we're starting to see developer-driven DAST testing expand, extending the use of DAST beyond the hands of AppSec QA and fully within the dev CI/CD automation pipelines. This enables DAST to be included in faster testing cycles. With automated security scans in the pipeline, it yields many benefits that lead to faster discovery and fixes. Developers are alerted to any new vulnerabilities before they hit production, optionally breaking the build to ensure that a review happens before the release, and testing can be run against underlying services and APIs instead of being limited to the customer-facing application, leading to faster identification of the underlying issue when a bug is found. With DAST scans aligned with functional test scripts, only the portions of the application that are being worked on remain in the context of the code they are working on. Scans that run automatically and integrate with existing processes and tools keep security and development teams moving quickly, which is obviously the ultimate goal. They remain focused on fixing critical issues, not scheduling scans. This approach typically yields better results than the recent increase in an IAST method. Passive IAST doesn't crawl the application and is dependent on the user creating functional testing scripts and manually exercising the application. DAST not only has these capabilities, but it's also effective at discovering the attack surface of the application on its own. This becomes a question of how much do you trust QA to create a script for every scenario and code path? Unless they can cover those scenarios 100%, you'll still need DAST to find all the attack surfaces. Testing early means organizations don't need to reorient their entire development process to a late-stage security gate as they did before. This allows for better scalability of DAST, which typically has been a major hurdle for security teams. Solutions that centralize the scanning are a key element of making DAST work at scale in DevSecOps pipelines. So a great way to set up DAST for both fast feedback and comprehensive scanning is for every check-in, run any functional test through DAST. This enables developers to get quick feedback on their changes in the same way as IAST. On nightly builds, though, run the more comprehensive scan that crawls the entire application, giving you full and complete coverage. So now I'm going to pass it back over to Sheldon to cover the last trend before we wrap up. Oh, and I do want to mention, we also will have a dedicated webinar on this topic as well. So be sure to register for that in the same registration place that you found this webinar.
Thanks, Brent. Okay, for our last trend, we're going to talk about machine learning and artificial intelligence, AI. Again, from our SANS survey, only 29% of organizations have automated most of their security testing. So obviously there's a lot of growth and opportunity when it comes to automation, but that's the way the market is trending: quicker, faster, easier. Another stat from the survey, fewer than half of organizations have included security tests and reviews as part of coding workflows. Again, automation is one of the biggest drivers empowering the shift left security. And this is backed by studies showing that companies who use automation are twice as likely to implement security testing. So while many organizations know there's a need for automation and some has taken place, there's still a ton of room for improvement. So our last trend or finding is that machine learning and AI are key to the next evolution of automation. Another good stat here. Gartner says that 95% of respondents use automation, only 33% fully automate their deployment pipeline. Furthermore, Gartner says that 32% of organizations manually integrate their security tools. So 1/3 of organizations are still manually integrating AppSec. So while the push to automate more of the tools used throughout the development process continues, we are also seeing more benefits in the form of automated remediation and machine learning. I know this is a trend report, but if I may, we have a good example, a good use case for the next evolution of machine learning. Fortify has innovated in this space with their audit assistant tool. Fortify's AppSec is a service offering. Again, Fortify on demand. It runs thousands of static, dynamic, and mobile scans per week, scanning billions of lines of code. So Fortify on demand takes customer application source code, runs the scan, and then as a value-added service, passes these raw scan results to a team of auditors who are subject matter experts. And these auditors identify and prioritize any noteworthy findings while also removing noise from those results. So Fortify on Demand customers receive actionable results that enable them to focus on fixing critical issues. But the Fortify Audit Assistant service, our use case for machine learning advancements, Audit Assistant uses machine learning algorithms to feed off the hundreds of millions of anonymous audit decisions from Fortify on Demand experts. And then those decision models are actively used and developed for Fortify on Demand. But these can also be automatically applied to our on-premise Fortify Static Code Analyzer results by using Audit Assistant. So in the future, we'll see more AI-assisted auditing from other AppSec vulnerability types, most likely starting with a subset of SaaS findings. There are lots of use cases for machine learning advancements. Our software composition analysis product, Debricked, does this with Open Source Select. And Open Source Select compares and analyzes the health of all open source on GitHub to make better decisions when researching a library or a framework. All right, I'll pass it back to Brent for some final thoughts and wrap up. Over to you, Brent.
Awesome. Thanks so much, Sheldon. So there you have it. The application security industry really continues to evolve at a rapid pace as organizations recognize that software security risks need to balance with business imperatives that accelerate the speed of digital innovation. The trends we've discussed here fit into a modern development framework where security is developer-driven and focused on actionable results that enable digital innovation. We'd love to hear from you, though, on these trends, things we missed, and anything else that is on your mind. Which of these trends interested you the most? Which ones are your organizations paying the most attention to? Are there any other AppSec innovations that you're watching closely? So feel free to leave a comment in this webinar. Reach out to us on Twitter, LinkedIn, our website, or anywhere else you can find us. Now for some closing business. Without going into a lot of detail at the end of a webinar on how our entire portfolio addresses each of these trends, which, spoiler alert, it does, I'll just say that Fortify enables you to build software resilience for modern development with a 10-year-long industry-leading AppSec partner you can trust. Fortify static, dynamic, interactive, and open source security testing technologies are available on-premise, in a private hosted cloud, or as a managed service, offering organizations the flexibility they need to build an end-to-end software security assurance program. And a lot of our solutions, products, and even topics discussed today on most of these trends can be found on our world-famous Fortify Unplugged YouTube channel. With over 70 videos on tons of different topics, it's definitely worth checking out and subscribing if you haven't done so already. And finally, before we close, I just want to remind everyone here that this webinar is the first in a 4-part series. This webinar was meant to be a quick look at these trends, while the rest of the webinars are a deeper dive into a few of the most important trends on the list to us. We will have some customer panels, best practices, feature showcases, and more, so be sure to register for the rest of the webinars. You can do so from the same registration page you used to register for this webinar. You can also find a link to the webinar series on our website, so visit fortify.com to learn more. While we aren't hosting a live Q&A for this webinar, we will be having them all in our upcoming webinars in this series. But feel free to ask any questions you have, along with any feedback and comments now, and we'll be sure to reach out with an answer, and we'll also be posting a post-webinar blog covering all the questions asked. So with that, I really do want to thank you so much for joining us and taking the time out of what I'm sure is a very busy schedule to spend some time with us here. So from all of us here at Fortify and CyberRes, we really hope you enjoyed this webinar, and we hope you have a great rest of your day.